Ladies and gentlemen, thank you for standing by. Welcome to the Building OpenStack Block Storage into Your Cloud Infrastructure Strategy webinar. During the presentation, all participants will be in a listen-only mode. If you'd like to ask a question during the presentation, please use the chat feature located in the lower left corner of your screen. If you need to reach an operator at any time, please press *0. As a reminder, this conference is being recorded Tuesday, November 19th, 2013. I would now like to turn the conference over to Seth Fox. Please go ahead.
Thank you, Matt. Hi, everyone. My name is Seth Fox, and I am the VP of Operations for Solinia. And as Matt has indicated, I'll be the moderator today. I want to thank everyone for joining us this morning, this afternoon, or this evening, depending on where you are. Before we get started, I just want to give you a quick overview of your hosts today. First up is SolidFire. SolidFire provides an all-SSD-based storage system that is focused on large-scale IT infrastructure. Their block storage architecture delivers best-in-class QoS experience with higher performance, with lower cost per gigabyte relative to traditional SANs. And I think the main reason everyone's here today is their OpenStack Cinder API and 100% REST-based API for management. Also sponsoring today is Solinia. Solinia is a software and services company designed to deliver cloud strategy, architecture, and integration to enterprises and service providers and SaaS providers worldwide. Additionally, with our speakers, I'll give you a quick overview of them. We've got Ken Peppel, who is the CTO of Solinia. In addition to working with our customer base, he's also led some of the largest OpenStack deployments worldwide. Prior to Solinia, Ken was the Director of Cloud Development at Internet Network Services, where he led their public cloud efforts that were based on OpenStack. Also joining us today will be John Griffith from SolidFire. He's the lead OpenStack engineer with SolidFire. John is also the project technical lead, or PTL, for the OpenStack Cinder project. What I'd like to do real quick is put up a quick survey just to get a sense of our participants today. So if folks wouldn't mind just letting us know sort of where you are, that will help our presenters get a better understanding of where everyone is in their process today and guide the conversations that way. I'll leave it up for about 5 more seconds, and we can get rolling. Looks like we got most of the responses in. I will close that out. And now, with that, I will hand it off to Ken Peppel, who will take us, who will start us off today.
Excellent. Thanks, Seth. So the first thing that we'd like to talk about is a little bit of the background to get everyone kind of up to the same speed of what we're going to be talking about here. And then I'll hand it over to John, who will dive much deeper into the specifics around block storage. So just to level set for everyone here and give you background, OpenStack is an Apache 2 open source project started back in 2010 by Rackspace and NASA as they got together to provide and create a project around being able to create a massively scalable infrastructure as a service cloud software. And over the past 3 years, this has grown from a simple 2 projects into now almost 9 different projects to cover different areas of what you would need for an infrastructure as a service. And these services projects have been divided into about 9 different projects, as I said, as well as 2 categories. There's a number of tenant services, or services that users would actually subscribe to be able to use in their computing infrastructure. And then there's a number of shared support services, things which are in the background to help them carry out and actually support these tenant exposed services. Those main services that you would interact with are things like compute, network, and storage. And in particular here, we're going to talk about object storage as well as block storage. However, there are a number of supporting services or shared services, as we talked about earlier, specifically things like identity, metering, orchestration, that allows you to use these tenant exposed services a little bit better. OpenStack was really designed to drive industry standards and accelerate cloud adoption for everyone, not just people that wanted to use a public cloud, but also people who wanted to have a private cloud or some kind of specialty cloud that was out there, and especially to avoid the end of cloud lock-in. What we see with OpenStack today is OpenStack has grown into an extremely flexible architecture for both deployment as well as writing new services. It supports a variety of different what we call resources. And these resources are things like hypervisors or storage providers or different even SDN or networking providers. It's fully addressable by APIs to allow each one of the services to stand alone. And what we've seen is a large number of vendors have actually backed this to create multiple backends off of either their hardware or their software for these services. The initial use cases for OpenStack were, as you can imagine, since it came out of an infrastructure cloud server provider, was to provide infrastructure as a service by service providers, but also things like creating and hosting web scale-out applications, performing big data, or even using it in SaaS providers. And over time, we've seen many more use cases be built out on OpenStack. So with that background, we move to the next slide. As I said, OpenStack actually has multiple ways to do storage, and it has multiple services there. Today, there tends to be two major services that people will use to be able to use some kind of storage within their cloud. One of them is object storage, and the other one is block storage. Object storage tends to be, and was one of the first services for OpenStack. It came out of actually Rackspace's cloud files. And basically, object storage is something that people are looking to be able to actually store and then retrieve files. It's fully distributed, but eventually consistent object store. However, it's not something you can actually mount or have POSIX type access to within your cloud instances. It's really well suited for backup and archiving, as well as things like CD integration. And where you see it is, it's very similar to Amazon's S3 model. As opposed to object storage, which is really tends to be for backup and archival, we also have block storage. And block storage is the more traditional storage that most people will think about and use within their computing infrastructure. It allows you to have a volume or a block store unit that you can attach or detach from your virtual instance in the cloud. And it gives you a place to have persistence that you can still actually have hopefully some kind of POSIX or actual mountable access to your files. It's similar in some ways to Amazon's EBS, Elastic Block Service, and it tends to be for the more traditional ways that most people will tend to use cloud infrastructure and cloud storage within their enterprise. The other part of it is there's a wildly different workloads that people will be looking to use on this. So object storage is really for more static content, and it tends to have kind of larger files that have a sequential read or write to it. And you tend to get, in general, lower performance out of it, especially when you look at latency. On the other hand, block storage tends to be highly dynamic, and it's for your smaller random read-write or things that have highly burstable I/O. It also tends to be, especially depending on what backend you use, optimized more for latency to be able to use in your traditional databases, messaging, and production applications. While these two services are the most common services to deploy, and they're the certainly most mature, there are other services being developed within OpenStack. And in the future, you're going to see services like folders or files as a service. So instead of getting the abstraction of a block storage volume or simply a place to put objects, Manila will be a project that will be coming that actually gives you a file system as a service. So there will be other things coming. However, these are what we see today. Cinder has a relatively small number of features, but widely applicable features to be able to use across almost everyone's environments. The two primary ones are the creation and deletion of volumes, and then the attach and detach. So basically, via an API call to Cinder, you can create or delete any volumes that you'd like out there and create them in sizes or types of services that you would like. After you've created them, you can attach them or detach them basically to any server that you have in your cloud. Now, today you can't actually attach them to multiple instances that you have, but you can attach them and then detach it and then attach it to a different instance within your environment. There's also a number of features to preserve availability or persistence. And today those tend to be snapshots, where I can take an exact copy of a Cinder volume and snapshot it or freeze it at a point in time. Or I can back it up. And backup is a slightly different definition, whereas with snapshot I'm taking an exact copy of it. So if I have a 10 gig volume, I get a 10 gig snapshot. Backups back up the content within the volume and back it up to some object store. And so I can preserve content either way there. I can also use volumes or block storage to be able to boot from. And so boot from volumes can be made into images that I can then boot my actual instance off of. And likewise, I can actually snapshot that back to be able to save that back into the object store. And so you see these three classes of traditional or features within Cinder. However, there is the ability within Cinder to create extensions for vendors. And so if the vendors have specific features within Cinder or within their back end for Cinder, they can actually provide that and expose that through extensions to Cinder that are specific to them. So if they have special features, they can create an extension to the API, and you can use that specific extension of the API to access proprietary or special features which are not in the mainline Cinder. So as I said before, OpenStack has a large flexibility or a great flexibility in being able to provide different architectures and designs. And this is specifically true around Cinder and Cinder's deployment options. Today, there are over a dozen, and I think it's actually over 24 now, different backends that Cinder can be deployed with. And so when I talk about backend, Cinder provides an API and an orchestration service, and it actually orchestrates some some deployment backend. And those backends may be things like a traditional Linux iSCSI, or it could be something like, say, a SolidFire. And we have different pluggable backends that we can use. And as of, I believe, the Folsom release, you're actually configured to use multiple backends, for example, if you'd like to provide different levels of service. So for example, you could have a cheap and deep option where you're just using, say, Linux iSCSI on traditional a Linux server, and then you could possibly have a much higher performance one like SolidFire. And so it provides different levels of service by these different backends that you can provide. Within the Cinder service, you actually have a number of different daemons as well as some supporting software there. And if you get into the actual configuration deployment of it, it's a very traditional distributed application which looks actually very much like OpenStack Nova or the compute service, where you have a number of API daemons that you can run for availability. You have a scheduler to be able to adjudicate requests and route them to the correct back end. And then you have a few service daemons which actually orchestrate those back ends for you. And that's all supported by a database and a message queue. There are a number of high availability configurations, and high availability will mostly be determined by how you're going to support your database and your message queues. These patterns that people are using today tend to be very similar to the ones that we use for the other OpenStack services. So being able to create either master-slave or some kind of failover service for the database, and then some kind of messaging queue that is pooled. But those same options actually apply here to Cinder. Now, as I talk about some of the other things here, I'm actually going to turn this over to John, and John can give us a little bit more detail here on some of the ways that we can change backup and snapshot destinations, as well as transport protocols. And then he'll go much deeper into different areas here on Cinder. where he can actually talk in more depth about both Cinder and how SolidFire enables a better Cinder deployment. John?
Cool. Thanks, Ken. So Ken gave a great intro on Cinder and the block storage project and what it's all about. Some things I wanted to touch on that a lot of people I talk to when introducing this get a little bit confused on is how to actually view it from a higher level. So I'm going to kind of go over what Ken just talked about and kind of give another take on it. One of the ways that I describe Cinder to a lot of new folks is as storage as a service or software-defined storage. It's somewhat of a controversial term, but this is the context that tends to work a lot for people. And the whole concept is what we're doing is we're allowing you to have multiple types of storage backends or storage devices, block storage devices. And what we're doing basically is we're abstracting all the differences and things like that into a common API and giving you basically just a pool of block storage resources that you can utilize. The reality is, in terms of the basic functionality and the basic characteristics of those storage devices, they all basically do the same things, as Ken pointed out. Some are better at some things than others, and that's where the differences really come in. And you can really start to expose those things through things like extensions, as Ken pointed out. Ken pointed out also the ability to do multi-backends. The concept there, for people that aren't familiar, the way it used to work in OpenStack was if you wanted to have, say for example, a default Linux iSCSI LVM based storage backend and you wanted to add a SolidFire backend, what you had to do in the past was you actually had to deploy another Cinder node and have a whole new volume service running on that node. The reality is when you get into using these backends like SolidFire or NetApp or Ceph or whoever it might be, when you get into that state, what's happening is that volume node is actually, that service is doing nothing more except acting as a proxy for that vendor's API, in which case having an entire server dedicated for that is a little bit overkill. So what we did is we added the ability to do multiple backends on a single server. That works great. The only word of caution there is if you're actually using the LVM service, the default LVM service, you might not want to do that because all of that storage is actually being served from that backend, from that node. So he touched on the high availability pretty well. There's really not too much else to tell there. Right now, configuring high availability in OpenStack and in Cinder in particular is a very manual process for the sysadmin that's done outside of OpenStack. So it's a matter of configuring the components like the database and the Rabbit and the message queue and everything else, all doing that outside of OpenStack on your own. Going forward, those are things that we would like to definitely focus on and make easier, have more integrated and things like that so that it's not quite as difficult to do. But for right now, that's where things are at. The backup and snapshot destinations, the main thing there that I'd like to talk about is on the backup side. So in backups, we basically do a dump of a block storage volume from Cinder into an object store. As of Havana, we now have the ability to configure different backends. It used to be the only backend that you could back up to was Swift. But we now have the ability to do that to Ceph Object Store, as well as for the traditional tape folks out there, Tivoli Storage Manager also has a driver plugin. So what you can do is in your config file, you can specify what type of backend you want to use for backups. So just like you can specify what backend to use for the actual block storage, you can also do the same thing for your backup service. So that's kind of a nice feature. The primary transport protocols that work extremely well in OpenStack, iSCSI, and there is some fiber channel work going on as well. iSCSI really is, in my opinion, one of the most flexible ways and the most scalable methods to use. So next, just a second. There we go. I have a little lag there, sorry. So next I wanted to talk about an example reference architecture that we have. So there's a built-in reference architecture for OpenStack, which is in Cinder, uses basically logical volume manager to deploy volumes and things like that, and that's a little bit different. What I wanted to talk about was an actual reference architecture using SolidFire. So in that particular architecture, we have a single node running all of the Cinder services, because as I mentioned again, it's mostly just a proxy or a gateway into our API. So that's not really, it's not a heavy load for that server. We take a SolidFire 6010 and configure that as our backend storage. And what we do is we use a dedicated 10 gig iSCSI network for our data traffic, so that we can get plenty of performance and there's no concerns or issues there. The key things that get really interesting is how you actually utilize that storage and how you utilize Cinder. One of the use cases that I find most interesting is to actually do bootable volumes and do what we call copy an image to a volume. So the things that gains you, in OpenStack, when you create an instance and when you spin up an instance, the way it actually, in the default mode, the way it works is it goes out to what's called Glance, which is an image repository, and it does an HTTP pull of all the bits and the data for that image down onto the compute node and builds an ephemeral instance that spins up and runs. You don't have any persistent data storage on there. Everything is ephemeral. And this is where Cinder comes in. Now you can attach persistent storage via iSCSI. But what's cool is you can take that a step further and you can actually create a Cinder volume now and actually load the image onto that Cinder volume. So now you have a bootable Cinder volume with a persistent instance on it, a persistent image. So what gets really interesting with that, when you're using something like SolidFire, we have things like inline dedupe and compression and things like that, and very fast cloning and snapshots. So what you can do then is you can cut Glance out of the picture for your customers. So we have a number of customer deployments where what they do is they have a single, say, 500 gig development image that they have uploaded into Glance. And what they'll do is go ahead and just download that onto a Cinder volume one time and have that as sort of a template or a golden volume. And then from that point, any developer in their team can just do a clone or a duplicate of that volume and spin up their instance in a matter of 20 to 30 seconds and be done. They don't have to go and incur that overhead of downloading it from Glance every time, and they've got something that's persistent, so they can modify it and tweak it and do whatever they need to do, shut it down and come back to it later if they want. And the beauty of that is, because we do the deduplication, most of those bits end up being deduped, and of course that's a huge savings in terms of the space usage. So the next thing I wanted to talk a little bit about what's new in Havana. So Havana was the release that we just came out with for OpenStack here last month. And there's a few new features inside of Cinder that I wanted to talk about. One of those is the ability to do volume migration. So we had talked about the ability to have multiple backends and things like that, and how HA works and so on and so forth. But one of the things that you have to consider is if you have all of your volumes deployed on a certain backend, what happens when you actually want to take that backend out of service and introduce a new one? Or what happens if, for example, you have to do a firmware update and people can't use that backend anymore or something like that? So what we did is we put in an API mechanism to allow you to actually migrate the data off of one backend and transfer it over to another. So it is a live migration. Depending on the backend you use, it will determine how long that migration takes and how robust it is. But the whole goal is to basically have live migrations that eventually will be completely seamless to an end user. So an admin, for example, would go into the API, request that the migration is performed. The end user still continues to go about his business and use the volume in whatever ways he's using it. And then when everything's ready, the admin can just pull the plug on the old volume back-end service, and things just pick up on the new one. So that's a really big advantage that we've started work on. So it's in the first iteration for Havana. There's a lot of improvements that are planned and coming down the pipe in the next release. So in the next 6 months, we'll see a lot of improvements there. Another big feature that we added was the ability to extend an existing volume. So the idea here is, for example, if you created a volume that was 50 gig, for example, and somewhere down the road you decide, hey, wait, I actually need 100 gig, so on and so forth. Instead of actually having to deploy another Cinder volume and attach it and use it and go through all that trouble, now you actually have the ability to just go ahead and extend the size of that volume. So that's a really nice feature, and it's handy to have. And then one of my favorites is the ability to actually transfer ownership of a volume among tenants. So inside of OpenStack, you have tenants. All of the resources are isolated between the tenants. So with transfer volume, what you can do now is, for example, if you're in Department A and you have a volume with certain data on it or certain information or something like that, or maybe one of these images that you created, you now have the ability to go ahead and give that to Department B. So what happens is you go into the API and you create a transfer. It gives you back a key. You give that key to whoever you want to give it to in Department B, and then they can go ahead and claim it and take ownership of that volume and utilize it. The other thing, we talked quite a bit about backups, and we keep mentioning that. One of the things in the backup code for previous releases up until Havana was that it only worked for certain backends. So mostly it only worked for backends that had their own internal implementations or things like that. So as of this release, we have a generalized backup. So no matter what backend you use, you can do those backups to the Ceph object store or the Swift object store or the TSM that I mentioned. So there's a generalized mechanism. It may not be as efficient for some as others, but it is there, and it makes it so that everybody can play. So there's some things to think about when you're deploying Cinder. A couple of considerations and best practices to keep in mind. The first is anytime you're talking about cloud and you're talking about OpenStack in particular, you're usually talking about massive deployments. And you're also talking about deployments that are going to change over time and be dynamic. So one of the top things to always think about is plan to scale. Depending on your use case and what kind of shop you are, this might be something as simple as just continuing to add Cinder nodes. The thing about OpenStack is it is horizontally scalable. So to gain more, all you have to do is, you don't throw more disk drives into the system. What you do is you just add more nodes to the system. So the scaling thing is something definitely to keep in mind, and keep in mind that it's horizontal scaling that you're going to want to be thinking about. So is your backend device horizontally scalable as well as Cinder, which is horizontally scalable? The other thing to think about is in a cloud environment, you're going to have varying workloads. So there's going to be significantly different workloads throughout your environment. If you have, for example, 200 tenants, they all might be doing different things. Some may be running databases, some may be running web servers, some may be doing some sort of test dev environment. So because of that, it makes the cloud a little bit challenging, because, especially with block storage, because you have to try and figure out how do I actually plan and deliver for all those varying workloads. So that's something definitely to keep in mind. The other thing I touched on was multi-tenancy. So in these cloud environments, especially if you do things like public clouds, you're going to have all kinds of different tenants and different people accessing these systems. OpenStack does a really good job of segregating those tenants and keeping them isolated and dealing with security and things like that. But you also want to think about your back-end storage devices as well. Does it have the concept of multi-tenancy, and does it have any sort of security enhancements or anything like that to take care of that? Another problem that you need to think about is what's called the noisy neighbor issue. And the noisy neighbor issue, for example, is if you're all sharing one particular storage device. So tenant A, for example, is running a database, and tenant B is running his database or test dev environment or whatever. The things that you can run into on some systems, some back-end storage systems, is if, for example, tenant A is doing some heavy read access of the database, he may be stealing all of the IOPS off of that back-end device. And the result is tenant B then is starved and gets no performance and can't get his work done. So that's a huge problem. So you definitely need to take a look at things like that and consider that and keep that in mind when you're choosing your back-end storage implementation. And then, of course, one of the most important things, especially when we talk about the scales that we're talking about and all of the automation and everything else, fault tolerance as well as failure recovery. Things happen, things break. They always do. It's just a fact. No matter how hard you try, you can't develop your way out of failure. So these things can be on the Cinder side or they could be on the back-end storage side. So you need to take into consideration how you're going to deal with that, how you're going to deploy your configurations to actually meet failure scenarios and recover from them quickly and efficiently. You need to figure out things like, depending on the back-end that you use, if you lost your Cinder service or your Cinder node, for example, do you still have a way to get into the back-end storage device that you're using and remap all the tenant volumes and everything and get everything back online? Or are you stuck? Those are things that you need to think about. And then, of course, also, on the back-end itself, you need to figure out what exactly the failure risk for that device is. Is it a fault-tolerant back-end? Is it a clustered storage device? Things like that. So those are all considerations that you definitely need to take into consideration when you're deploying. So I kind of touched on some of these already, but these are the things that in terms of the actual back end, these are basically the key bullets, right? These are the takeaways that you should get from that previous slide. First, you need to look at performance. And performance isn't just, oh, it's a super, super fast storage device. Performance is things like, is it performant across the board? Is it consistent? Can I control that performance? The other really big one here is scale. I mentioned before, when you talk about OpenStack and everything, you definitely talk about things at very, very large scales. So do you have a storage device? You need to have a storage device that you can scale horizontally, and you can continue to grow as your needs dictate in the future. And then, of course, high availability is huge. We talked about the failure scenarios and things like that. You definitely want to have something that, if you have 1,000 volumes sitting on this device, or if you have 100 and some odd tenants, you can't really afford to have that back-end storage device just go away and be unrecoverable, or have it take days or even weeks for you to recover all that data. You need to be able to recover quickly and seamlessly. Data reduction is a huge thing to think about in cloud deployments. The reason why is because the reality is many of these customers, many of these tenants, they're going to be deploying Linux servers or Windows servers even. There's a huge potential for data reduction there that will allow you to save a lot of money and extra costs. And then finally, the Cinder integration. Ken had mentioned there's well over a dozen, probably closer to 2 dozen, different backends that are integrated and backend storage devices that are integrated inside of Cinder. The thing to keep in mind is it's fairly easy to write a functional driver that works and deploy it and get it submitted into the OpenStack codebase. It's completely another thing to actually understand how all of the components up above inside of OpenStack are utilizing that and keeping everything up to date and keeping things synced so that they work. OpenStack is a very fast-moving project. It's constantly under development, always new features coming along, and so everything inside of that ecosystem needs to grow together. So that's a really important thing. So some of the, I touched on the reference architecture and some of the things that we see there, and I wanted to kind of just real quick just talk about some of the real world use cases that I was kind of thinking of and keeping in mind with those. We have a public cloud provider named iWeb, and they do a lot of exactly what I described, allowing their customers and their tenants to do things like do bootable volumes and boot from volume for their instances and so on and so forth to get all of the efficiencies and benefits and speed out of that. In addition, what iWeb does is they utilize the SolidFire cluster, which gives them the ability to actually sell different IOPS provisioning to their clients. So their clients can actually pay based on what they're desiring for performance. They can select the IOPS levels. So on the SolidFire cluster, the QoS allows you to set minimum IOPS, maximum IOPS, and burst IOPS. So what this translates to from iWeb's perspective and their customers is they can actually purchase tiers of storage in performance for that storage. We also talk about, in more of a private cloud type of environment, we have quite a number of customers that are doing things in the same manner. They're just doing it locally for their dev teams. So we have specific Web 2.0 companies that are doing things like spinning up hundreds or even thousands of instances on SolidFire volumes, for example, and using that in their test and development environment. So through OpenStack and through the SolidFire cluster, they're able to do that extremely efficiently and extremely quickly, and they're able to do things that they weren't able to do before. So that's kind of a little bit about where we are and where we've been with Cinder and the block storage project. A little bit about what's coming up in the future. It's really early in what we call this next release is Icehouse. We're still working on defining a lot of the features and functions that we want to attack and what we want to prioritize. Some of the big things that we really want to look at are furthering the integration with what's called Trove, which is Database as a Service. This is one of the supporting services that Ken had mentioned that sits on top of the tenant services. We really want to develop that further and get some more efficiencies and enhancements there. And basically what that's doing is allowing you to literally deploy a database setup through the OpenStack APIs. So once you have all the other components down below in place, then you can go ahead and do this. And it's got a lot of potential. It's a really promising project. There's also things like big data as a service. We're looking at doing Hadoop and things like that. So there's some really interesting things coming for Icehouse. Definitely, keep your eyes peeled. We'll be blogging and posting things, between our website and Twitter and everything else, talking about these new features that are coming as we develop them. And there's a lot of good things coming there. So. And with that, so I'm going to take a look here at the questions.
So John, if you want, I can read off the questions, and we can go from there. Sure. Okay. So the first question we've got is earlier, John, looked like you were talking about how images are transferred to volumes. You had also mentioned the possibility to eliminate glance with SolidFire technology. The question is, they wanted to confirm that they heard that correctly, and if so, can you elaborate on that a little bit more?
Yeah, sure. So it's not so much eliminating glance, so I should clarify. The idea is, so I had mentioned before, the way the default OpenStack, the way it works is every time you boot an instance, it actually goes out to the glance server and the glance repository and does an HTTP transfer of all of the bits for that image. So that's every single time. The way that I was describing SolidFire technology in Cinder, eliminating that is it doesn't actually eliminate glance, but what it does is instead of doing that every time, it only does it once. So you go out and you do that once, you do a copy image to volume one time, and then you just clone that volume. It's much more efficient and it's much faster. And then also, for some people don't like having ephemeral instances. They don't like having to rewrite their apps to figure out how to do things like recover from that failure mode, spin it up another instance, so on and so forth. So having a persistent instance is actually a huge advantage for a lot of people as well. And then, of course, keep in mind, you can still do the same. You can do the reverse as well. You can have volume that you deployed an image on and modified and everything, and you can upload that to Glance as well, and then people can use that in the future. The key that I was trying to get on there was basically there are definitely more efficient ways to boot an instance in OpenStack other than the traditional download instance from Glance every time. So hopefully that helps.
Great. Excellent. So next question we've got is about any plans in OpenStack to implement provisioned IOPS similarly to EDF today?
So actually, that's a great question, and there already are. So that's already available. So by using something, specifically if you're using SolidFire, the admin has the ability to create what we call volume types. And those volume types can map to certain IOPS settings. This is the use case I was talking about. iWeb, for example, they sell this to their customers and so on and so forth. And that's exactly what that does. So the whole idea is, yes, you can provision, you can set these specific IOPS and do that. In addition, as of Havana, we did also start work on things like rate limiting at the hypervisor and things like that. So that's another option as well.
Great. Okay, so we do have another one in the queue. So this is talking about scaling. How do you really scale the Cinder API in a high traffic environment?
Yeah, so that's a really good question. That's one of those deployment considerations that you need to figure out, right, and you need to look at. If you are doing if you go the single node route, depending on how much traffic you think you're going to see from the API and things like that, this is something you need to consider. Do you actually need multiple API servers? So you can easily do things with Cinder, with all of the OpenStack projects. You can have multiple API endpoints and just put a proxy in front of them and just let it do a rules-based scheduling or load balancing or whatever. So there's lots of options there. One of the things that you can do in particular is you can start with a single Cinder node deployment, and then kind of depending on how things go, you can decide whether you need to scale that out or not, right? And you can grow that and grow into multiple nodes. The API question is kind of interesting because depending on the environment and depending on what's happening, that's going to dictate how heavily that API is used. Typically for block storage, what you see from a lot of people is it's not nearly as frequent as things might be in some other APIs, but it just depends. It totally depends on the deployment and the customers that you end up with.
Hey John, this is Ken. So just to elaborate on that, within block storage, the API nodes actually aren't in the data path. It's only being used as a control path there. So it's probably going to have a lot lower traffic than you're probably used to in an object store, where actually the API sits actually within the data path. So obviously it's a complex system sometimes, so there's different things depending on which different things you actually want to scale there.
Yeah, excellent. Thank you, Ken. Good point. Good point.
Great. So this next question, I think maybe for Ken. There's been a lot of talk of all these different systems and lots of different APIs from the OpenStack side, the Cinder APIs. What type of automation tools can we use against these type of systems?
So it depends on what you're looking to automate there. So we have people that are looking to automate within the instance, and they tend to be using things like Chef and Puppet to be able to install packages and things like that. And so you can certainly do something like that, but usually to be able to bring block storage in and things, you're really looking for something that does what we call orchestration, something that can actually create instances for you, hopefully multiples of them, attach block storage to each one of them, configure your networking and the number of networks that you need. And today, you have a number of options to be able to do that. There are commercial options out there from, vendors like Dell, which has its Stratius, and Service Mesh, which was recently bought by CSC. But there's also OpenStack projects. So OpenStack Heat, which is a new project in Havana, actually allows you to do that orchestration by able to create stacks, which is a number of applications, as well as network and block storage that you can add to those things. So it really depends on what you're looking to do, whether you're really looking to do configuration management or it's more orchestration, whether you want to use open source or you've got a proprietary vendor that you'd like to use for those. However, all of those, you've got open APIs for this. So you should be able to use, theoretically, anything that supports those open APIs.
Great. Okay, so it looks like I've got one more. Does Cinder work with Ceilometer in any way to handle publishing and storage of performance metrics?
I was going to let John answer that, but if not, I can.
So I'll let you go into the details, Ken, but the short answer to that is yes. So Ceilometer does go ahead and do periodic tasks and pulling into Cinder and extract information. There's still a good bit of work that needs to be done to add some more functionality there and some more features. But Ken, I'll let you touch on any details that might be more interesting there.
Sure. I think today mostly it's gathering events and some summary statistics out of there. So if you want to know, at a time how much block storage somebody has or which volumes they've created, I think you can find things like that out of Ceilometer today. However, if you're looking for how many IOPS they've used or how much traffic they're pushing across there, I don't think some of those things have actually made it to production yet within Ceilometer. And they're probably things you'll see in Icehouse or whatever we end up calling J later in 2014.
Okay. Got one more question about economics. Is there anything that you can be pointed to understand the TCO of the OpenStack SolidFire deployment model versus other deployment, other storage solutions bundled with OpenStack?
Yeah, so that's a really good question, and the thing is in terms of the TCO, the things you have to look at, as I mentioned before, are things like the dedupe, the scalability, things like that, and then also the performance. The thing to keep in mind is with our solution in particular is you get to do things like set those minimum IOPS and maximum IOPS and actually divide up the performance of the system and actually pool it out as resources. The problem with other systems when you're trying to do things like fight the noisy neighbor problem and stuff like that, the only way to really guarantee any sort of performance or do anything with that is to actually just provision more storage, right? So just completely underutilize the back-end device. In exchange, what you get is you get better performance for all of your tenants and all of your customers. But that's not really a good option. That drives your TCO way up because now you're buying way more storage than you actually need. So from our perspective, the performance aspect is one huge TCO benefit. And then the other thing is, like I mentioned, things like deduplication and compression. Those are huge benefits as well. The other thing to keep in mind when you're talking about TCO is things like fault tolerance and fault recovery. The fact with our device, it's a clustered storage device. It's not a RAID. It doesn't have a single point of failure controller or anything like that. The thing is we can do things like lose drives or even lose an entire node in a cluster, depending on your configuration. And in most cases, it's completely seamless to the end users. They don't even know. And it's also self-healing, so all the rebuild is automatic. So when you talk about things like TCO, those are all the different things that you need to think of. In addition, you need to think about things like what you're getting for your money, right? So with SolidFire and OpenStack, for example, you're getting a platform and a company that's dedicated to OpenStack, actually invested in working in OpenStack full time, and not just on their component, but on the entire project. So they understand how things work, or we understand how things work and how things go together. And then we also have a first-class, top-notch, test team. So test and support, that's another huge thing to consider in TCO.
Yeah, I'd agree there, John. I also think, for customers that are looking and very interested in what their TCO, in either cost or TCO or any of those things, both Selenia and SolidFire have a lot of materials to help you along with this. Selenia has helped a lot of customers understanding their TCO and their kind of budgetary view of into the cloud and what it's going to cost and what are the benefits going to be. And in addition, SolidFire provides a lot of these, especially within the service provider market. If you're looking to be go-to-market, SolidFire and Selenia can help you both on that upfront piece, but also about how you might market this and go to market with it.
I think that looks like all the questions. Take a look at solidfire.com. Selenia blog has some additional details in general to give everyone sort of a broad picture. To thank John and Ken for time today. I think this was a great session, and if anyone has questions, please follow up directly. With that, I will hand it back to ReadyTalk to close us out.
Ladies and gentlemen, that does conclude the webinar for today. We thank you for your participation and ask that you please disconnect your line.